Alright, so now we're going to look at a way which you can express a dynamic equilibrium. A way for you to show that something is at equilibrium. And those are concentration time graphs. So here's our example of a concentration time graph down here. We have our reaction, which is 2A, which is gas, plus B gives you C. Alright? Now let's have a look at a couple of things on this graph before we see. So when we start at 0 is C. And you can see that over time its concentration increases. And here we have A and B. And this graph's probably a bit out of scale. I'll explain what I mean in a second. As they increase, so as time goes on, you can see that their concentration decreases. Now, this is the cool thing. Because this is a 2, that's a 2, so that means there should be, at all times, and again, the graph's a bit out of scale, twice as much of A as there is B. Now, things can happen which will disturb the equilibrium, like you could add a bunch of A, and that would shoot this straight up, and it may not shoot B up at all, but they would then rebalance after that. And they might not go back to their even 2-to-1 ratio, but yeah, but to start off with, they would be 2-to-1. So these graphs can be used to demonstrate the use of reactants. So you see here our reactants are being used up as our products are being created. So use of reactants to create products in a reaction. They're particularly useful when we want to say something, or we want to see if something is at a dynamic equilibrium. Remember, it's called a dynamic equilibrium because the reaction is going this way and that way at the same time. So it's not stable. Stuff is still happening. But we can show that this is at equilibrium because the lines are all parallel. So the lines are straight. This means they're not increasing or decreasing in concentration, because each one is going backwards and forwards at the same rate. So we can observe changes really well. For example, if at A here I increased a bunch, we added some, we would see this then go forward, and we would see this also shrink, and we would see this one go up till they again reached a new stable equilibrium. They would find a new equilibrium because it'd be a closed system. Now, as we said, dynamic equilibrium is achieved when all the lines are straight. So all the lines are parallel. And what this means is the concentration for all of the reagents, all of the products, are constant. That's how you know you found an equilibrium. Alright, I hope that made a lot of sense. Thanks for watching, and we'll see you next time. Bye now.